So this, oh, there we go. Thank you, Eddie. This meeting will be on flip-flops and shift registers, in particular, how we're using them in hobby electronics. If you've taken 2060, which is digital logic, you've probably seen both of these components before. But we'll be using them in more of a context of like, how do I actually work with it if I have an Arduino, which is the most popular like microcontroller interfacing method. There we go. All right. Oh, and I'm now presenting on my computer, so I have this fun little pointer, which I'm excited about. So this is our contact info. And you can get that more directly if we, there we go. So if you go to electronicsclub.osu.edu, you can follow along with our meeting slides. Eddie, are they up for spring?
That's a great question. Let me check.
So Eddie will be remedying that situation soon. So if they're not currently available, they'll be available soon. But you can follow along with the meeting slides. There's a few links in here if you have interest in a variety of things.
The meeting slides are updated for the 2021 spring semester. So on our website, just click that meeting slides link. And to the left of the right of that is also archive slides from before. Feel free to read that in your free time and stuff.
All righty. So this is our contact info. If you're not part of our Discord server, you can join our Discord server. That is the permalink, I believe. It should still be active. Announcements. Register for Make Ohio. I think registration is still open. Make Ohio is a OSU-based make-a-thon where traditionally a lot of people get together in like a gymnasium or some such and all work on electronics projects. And at the end, you present them to judges, and there's prizes. It has a lot of sponsored events. You can get money and some such. I think Electronics Hub is running an event this year, and we'll have a meeting on that a little bit later on. But this year will be virtual, so you can order materials and they'll be shipped to you, and it's a lot of fun. I participated in it. I think last year and got my team got second best overall, and it was a very good experience. You meet a lot of very smart people, and the smart people teach you more about how to do things. So meeting slides. All right, content overview. So how my meetings in particular are run, how I do quote deep dives. We start off with overhead or theory. So the ideas behind it. This is most of the content in say 2060, where you learn about what a flip-flop is, what a shift register is, and how they work, and a lot of the math behind them. But usually we're more interested in the practical side. How do I actually work with it? What kind of projects can I do with it? What are the further applications of it? How do I choose which component that I want for my particular project, in this case, shift registers. So we'll start with overhead. So what is a flip-flop? If you've had any kind of experience with this, a flip-flop stores a single bit of data. So you put in a 0 or 1 and it keeps it there. There are a few kinds of flip-flops that store this data in slightly different ways. They're made up of latches, which hold a certain value indefinitely when a trigger occurs. So it holds 0 for a while, and then you flip a switch. Now it holds 1, and you can't do anything with it unless you have other control circuitry. So latches are made up of logic gates, and they're also called, quote, bistable multivibrators. So over here we see a D flip-flop composed of only NAND logic gates. And this is a common packet, DIP package, LM358P. In particular, we're going to be focusing on D flip-flops because this is what shift registers are usually made out of. So this is what a D flip-flop looks like under the hood. There are also things called T flip-flops, which toggles. So every time it has a digital high, or it blips high from 0 to 1, it toggles the value on or off. And then JK flip-flops, which are controlled with 2 lines, the J and the K. And you can learn more about them in links later on, or you can take 2060. So Q, which is our kind of output, is held at the most recent value when the clock is off. So the clock controls the circuitry. So every time it clicks, it iterates one further. So Q changes the current D input when the clock is on. So every time it gets a clock pulse, it checks what is currently at D, and then it stores that value. So if it's 0 stored at that value when it clocks up, it stores a 0. If it's a 1 when clock is up, then it stores a 1. And this is our little kind of logic gate or logic table. And this is what it usually looks like in kind of theoretical notation or schematic. How does it work? They're logic gates with something called feedback. So D flip-flop is nothing more than just a useful combination of logic gates. NAND gates are often used in digital logic because there's something called logically complete, meaning you can do anything with only NAND gates. But it's also useful to visualize them with ANDs or NORs. So if you played with Minecraft Redstone, or you took, again, 2060, you'll kind of get more background behind how these things work. But we're not particularly interested in how they work, because we can kind of abstract a further level up. So what is a shift register? A shift register is an integrated circuit that holds a binary number, usually 8 bits, so 8 pins. The value on each binary digit can be shifted to the next pin to allow new numbers to be inserted. So you have a 1 over here. We shift it to the right. The 0 is shifted to the right. The 1 is shifted to the right. And then you have some new serial D input. And you can chain them together by connecting the serial output of one to the serial input of another. So if you have a bunch of these components all in a line, you can have a shift register that just goes on to n times 8 number of bits. And there's 4 types, and these 4 types have very distinct uses in different projects. So they're notated with SISO, SIPO, PISO, and PIPO, which are really fun to say. But what they correlate to are to serial input or parallel input. So serial input means that you feed 0s and 1s through a single line, and each time it clocks, it registers either a 1 or a 0, and it feeds that further in. But parallel input means that we have direct access to each of the kind of blocks, and we're all at once saying that the register now holds this value. And there's a similar thing on the outset. You can have either serial input, where you have an output of 0, 1, 1, 0, 1, 0, or you have parallel output, which says all at once the register reads 0, 0, 1, 1. So this is a common package, one that I'll show a little bit later. I think people call it the 595N, so that's more the kind of shorthand notation you'll find. A lot of components are just shorthanded by whatever the last few numbers are. So how does it work? Well, a shift register is just a series of D flip-flops. So this is a 4-bit shift register that I showed before. In particular, this is a serial in, parallel out configuration. So when the value of this particular unit needs to be shifted, it can go ahead and be shifted that way. There's a little bit more going on here. These little dots indicate AND gates, and these little circles indicate NOT gates. A lot of this is kind of abstract notation. So serial data is fed into the left, and it shifts to the right clock up. And this particular animation is very nice in showing this. Let's see if I can zoom in a little bit. There we go. So this is our data line up here. It's showing various zeros and ones we want to hold in the shift register. We have the clock that iterates each pulse. And then every, say, 8 clock pulses, we want to latch the register. That means that we are inserting data, but whatever was most recently latched is what's showing. Now that we're done inserting data, we latch it, and now it's showing that new data. So you can see down here, it's shifting between 101010 to 010001. Which is pretty cool. All right. So how do I work with it? This one in particular is exactly what I showed before. It's serial in, digital out, or sorry, serial in, parallel out. There's a number of outputs here. There's a serial in right here. You need to make sure that your operation voltage and ground are connected. And if you ever intend on using this in a project or anything, the thing that I pull my hair out every single time I reintroduce myself to this is making sure that this is set low, disable output is set low, and retain info is set high. If you don't have this, things go real haywire real quick. So this is my word of warning to make sure that you know how to work with whatever component you're using and know what to set high and what to set low. All right, so this is some Arduino code to do what that animation was doing earlier. If you are unfamiliar with Arduino, I really recommend looking up a tutorial, buying yourself an Arduino. You can get a knockoff, something that looks like this, for about 12 bucks. They're very worth it. You can buy a kit for about 20 bucks. And you can do a crap ton of stuff. And in the electronics sub, we like to center around Arduino interfacing. But this, if we kind of read down, so we're storing in data a array of 8 Boolean values, 0, 1, 1, 0, etc. So this function here writes a new value to the register. So you can see the clock pin is latching, either unlatched or latching the entirety of the data. And then for each value inside of the register, we're opening up the serial clock pin. We're inputting whatever our value is, and then we're pinning up whatever that value was to insert it in, and that shifts it to the right. And then once all of our values are inputted, we latch, and now it is displaying whatever was there. The tutorial that I used, you can find on this link if you're clicking through the slides. There's also an alternative one, which is where I found the animation. Has a lot of good explanations behind it. And this will be in an example I'll show a little bit later. All right. What can I do with it? Well, the really cool thing here is you can control 8 LEDs with only 3 digital pins. So normally, if you have this Arduino, you would say, oh, I need to control 8 LEDs, so I'll hook up all 8 pins to each individual one, which is terribly inefficient because that you have all of your LEDs. Say if you wanted to control 20 LEDs, well, you ran out of pins real quick. So this extends our kind of life of our Arduino or any other microcontroller that you use. So concept in digital electronics is using the minimum amount of things that you need. Something a little bit more fun, an array of the same concept. So this is just taking the concept above and doing it for multiple times. In particular, it uses something called multiplexing to extend the register even further. So the idea behind multiplexing is that you have lines going in rows as well as columns, and you can pick a particular LED by lighting up both the row and the column. So you can see here, this one LED is chosen because this is set to ground, while its row is set to high. All right. So this is probably a good time to shift over to my screen real quick. So I have actually implemented over here a couple of these in person. So we'll see here. Oh yeah. I think there we go. So this right here is the shift register. I can't see both my video and my camera at the same time, so I'm kind of flipping back and forth, but oh boy, the video just cut off completely. That's fantastic. Oh, there we go. Okay. So this is the register. I'm going to be controlling it with something called an AT-Tiny, which is just a small Arduino. And you'll see it only has 6 pins. So even if we wanted to control 8 LEDs, we wouldn't be able to. But with this kind of scheme programming, we are able to control it. So you'll see some kind of random blips. And now we're adding up or kind of showing binary numbers going from 0 to 255. Which is pretty cool. So if you have any data that can be displayed on 0 to 255 states, you can display it with this. And if I go ahead and, oh boy, where did I put that? Oh yeah. I yoink that out of there. Now put it into this fella right here. You'll just give me one moment. There we go. See. So that LED matrix I have right here, I have a little 4x4 matrix. And you'll see we can iterate going from each one. But you'll also see that for some reason, what this is supposed to be doing is iterating through every single possible combination of the shift register. But you'll see that not every single combination on the matrix is being lit up. And that's because we have here 16 LEDs, but we only have the ability to control 8 binary digits. So multiplexing does not help us control entirely, say, 16 LEDs. A way to get around that is to jump back and forth really quick. So you can light up, the way you kind of show 2 LEDs at the same time is in code, you light up one and then the other, and then you flip back and forth real quick. So the idea behind that also stays. If you have each individual LED and you just flip between them all real quick, it'll appear as if they're all showing in data. All right, so let's go back to sharing the screen. There we go. All right. So really fun thing to do is to take this one step further. Why do 1 dimension or 2 dimensions when you can do 3 dimensions? Something called an LED cube. This is very popular among electronicists. I've seen this in offices. Every single desk has one of these because they're just so fun to look at. In the kind of extra goodies section, I have a link to a tutorial of how to build one of these with only an Arduino, which is very nice. So this is a very nice project if you'd like to play around with shift registers or kind of LED matrices. So all of the previous ones used serial in, digital out. So we're interested in having very few lines of data going in and then a lot of lines of data going out. The way we can use the PISO or parallel in serial out is if we're interested in a lot of inputs, and then a few lines of data for outputs. So if we want to say control 8 buttons or have 8 buttons be inputs, we can use a parallel in serial out register. And that can be found in the IC 74165, occasionally abbreviated 165, just the 165 register. All right. So after I show more specific examples, this is more general applications. In digital logic, again, I hate mentioning it, 2060, ECE 2060, you work a lot with registers in this particular context. You can build your own breadboard computer. As a matter of fact, I have a link, a tutorial on that a little bit later on. Ben Eder has a series on that, where he goes much further into each kind of flip-flop, a little bit further into kind of what the registers do, et cetera. Does anyone have any questions about any of the content I've said? I've kind of sped through a lot of this. About any of the content on how flip-flops registers work, how we're working with them, or how this Arduino code works. All right.
Do we use this stuff in any other class that's not 2060? Like in the future for like electronics and stuff?
Oh yeah, definitely. Like
I know we would use it like specifically like that, the basic stuff of that, or is it all like integrated within what we're doing?
So are you asking if we're using anything that's
we don't.
If this club will use anything that's outside of 2060?
Oh no. I'm asking like in like future classes, because like obviously you're a junior, so like you would know like when we would specifically be using a lot of this type of stuff, because I haven't really used any of this since 2060, so I was just curious.
Yeah. So this will definitely. Let me think. So this has to do a lot with kind of digital logic. So digital logic is still used kind of everywhere if you're interested in state machines or building different things. As for classes, I know that, what's it called? Signals and Systems uses it
2050?
a lot. Yeah, 2050 and then 3050 as well. In 2050 deals with digital logic exclusively, but 2060 you get into both, or sorry, in 3050 you deal with not only digital logic, but you also have analog logic as well, or analog systems.
All right, cool, thank you.
Yeah. So let's see. Yeah, and a lot of this stuff applies for very useful things. I showed not controlling only LEDs, but you can use it to control anything that involves a kind of simple digital input or output. So if we wanted to control a whole lot of motors all at once, I don't know if you have like a miniature town where you have like a whole lot of windmills everywhere, like a model set, but you can have a MOSFET driver where you have a register hooked up to a lot of motor drivers, each inputting a small current to drive the very large current of the motors. All right. So there's a few kind of ideas behind shift register selection. Most flip-flops and registers can be found in either DIP or SMD packages. DIP means that you can put it on a breadboard. It has the nice little pin things that you can push down, or a perf board for that matter. SMD is almost or exclusively soldering onto a pre-made circuit. So there's, of course, SISO, SIPO, PISO, and PIPO. and they all have kind of unique uses. I mentioned two, which is the serial in parallel out and the parallel in serial out for kind of minimizing the amount of data lines you need. But there's also use for parallel in, parallel out, which is essentially just a whole lot of D flip-flops at that point. But so there's also use for serial in, serial out if you're doing, again, digital logic where you just need to store the values for a little bit. So the idea behind that is that have the idea of shift registers and then figure out which one works best for your particular project. This right here is a flip-flop package. You usually don't see an IC with only one flip-flop. It usually comes in packages of 2 or like 4. That's because it's a not very complicated component, so they package them together. So this is 2 D flip-flops. All right. So here's some kind of extra goodies. If you follow on the notes on the website, you'll have links to all of these. I kind of have a lot this week because I was very excited about LED matrices and cubes and whatnot. But if you want to get the serial in, parallel out that I used over there, you can buy it right here. It's only, there we go, 50 cents each. So it's not terribly cheap, especially if you, or sorry, it is terribly cheap if you so choose to order a lot of components together. You can order the LEDs with this. You can get your own breadboards. I like Jameco. You can choose to do whatever. But if you want to find that particular component, it's there. Same thing with the parallel in, serial out. If you'd like to try that button array, that is also there. Oh yeah, the example that I used, this is the tutorial that I used for the multiplexing idea. So controlling an array of LEDs. If you're interested in the little miniature Arduino that I used, it's called an ATtiny85. Here's a tutorial on it, and here's the buy link. If you're interested in controlling kind of really big LED matrices with shift registers, there's a YouTuber called Great Scott that I like a lot. And this was where kind of the first idea for this meeting came up. Here's a simple RGB LED cube project, also by Great Scott. If you're interested in how registers and RAM are used more in computer science, there's a link to a crash course on that. So registers are used extensively, like everywhere in computer science. That's how you store data, and especially RAM. If you're interested in, as I mentioned earlier, that 8-bit computer by Ben Eater, or getting more information on any of the latches or registers, he has that here. So this is a full kind of YouTube tutorial on how to build this. Let's see if there's a thing up here. There we go. This kind of full digital logic computer. So if you get really into that, you can go very deep. All right. Are there any extra questions going on at the end?
I have a question.
All right.
As someone who I just got in my major, I'm taking 2060 right now. What is one of the best ways to start using Arduinos and some cool beginner projects to do?
Yeah. I personally really like LEDs because they're fun and blinky. That's an opinion shared among a few of my peers as well. But I definitely agree and wholeheartedly suggest you buy a Arduino kit. You can find some projects on that kit and kind of do those. Learning electronics by kind of writing stuff down and having like a general concept doesn't work. So I do highly recommend. There are Arduino tutorials, which have a lot of projects kind of within them. If you have the more that you do, the more you have kind of skill sets where you can kind of build projects yourself. So once you know how to control LEDs, you can do different ideas with kind of state machines, or once you know certain Arduino programming schemes, you can do different things. If you're interested in controlling like a 7-segment display, you go on Google, you type in, how do I control a 7-segment display? And how do I interface it with an Arduino? And you kind of move on from there.
Okay, cool.
Yeah. And in the future, I will actually be doing a meeting on how to get started in hobby electronics for $20, $50, or $100, where we'll be going through various equipment you can buy for very cheap.
I have a question.
Okay.
So are there any other boards other than the Arduino that you might recommend?
I know I have a colleague, the treasurer, who swears by the Teensy,
Yes.
T-E-E, or
Mhm.
T-E-E-N-S-Y.
Yeah,
Isn't
so,
that also based on the same processor that the Arduino has?
Probably.
yeah, it's the same coding language.
Oh, wait. Yeah. Same coding language, different.
Yeah, same coding language. A little more powerful, but in a little.
Yeah.
Depending on which one you get, inexpensive. There's a lot of versions out there. I can give you a link to the website right now, really quick.
Yeah.
Yeah,
So
pjrc.com.
there are a few other kind of programming schemes that use kind of different language. It wasn't C or something. It was like C. But in your actual classes, if you're programming a microcontroller, I think we use Texas Instruments, which have their own programming.
Yeah, I believe
which
it's
is
Energy.
really hard and not very intuitive comparatively to the Arduino system. So the reason Arduino is so popular is because it's free and it's cheap and it's easy to learn, and it's very powerful. You can do most of the things on Arduino that you could do anywhere else. It may not be as fast, but it's an excellent way to get started. And then from there, you can learn different things.
All right. Thank you.
Yep.
Yeah.
A little last minute thing for while everyone's here. We have some officer positions open. So we have funding coordinator, couple plus workshop developer, social media manager, the website manager, and e-council rep. So if anybody's interested, you can email us at electronicsclubosu@gmail.com. The link should be, or the address should be on our website, bolded. Yep, send us an email if you're interested in running for an officer position, and we can get that sorted.
Oh yeah, if you become an active member, I believe we have shift registers at the club room. I don't know if Eddie can back me up on that, but they're a very common component. So if we don't have them, we can get them. But the idea is hopefully a lot of the stuff that we teach in these kind of online meetings, you can put to practice. In previous years before COVID, the way these meetings worked is that we chose an IC and then we handed out breadboards and everyone actually worked with this stuff. With COVID, we can't do that. So I do recommend, if you can, kind of putting some of this into practice somehow, somewhere. All right. Does anyone have any extra questions?
Were you talking about the Launchpad by Texas Instruments for 2560? Is that
Yeah,
the
probably.
specific class? Okay, I'm in that now, and we haven't even started on it. So
yeah,
is it like a lot more complicated than Arduino, or what? Like you said, it was worse.
I did discount the language too much, but you'll definitely see that it seems to require a lot more setup than Arduino does. Arduino is open source as well. So the coding language as well as the physical processor. So it's much closer to machine language, the kind of language that you use in the class.
Okay, thank you.
All right. Any final questions? All right. Next meeting will be held 2 weeks from now. Eddie will host it, and it will be on sensors. That's a lot of